Earlier, we established that it would be really, really difficult for living things to make its way to Hawaii. 2,400 miles away from any kind of land, Hawaii sits isolated in the middle of the Pacific. But yet, over the last few days, we have seen incredible video footage of a diverse amount of species. How did that happen? We know that just a handful of species made it here. But today, when we look on Hawaii, it is abound with different species, amazing ones, unique ones, endemic ones that only exist here. How did that happen? Well, we're going to dive into that right now. A phenomenon known as adaptive radiation gave us these beautiful creatures, and let's go ahead and figure that out. So what is an endemic species? An endemic species is an organism that has evolved in one location and is still only found in that one location. An example of an endemic species would be the Hawaiian tiger cowrie or the giant blue Hawaiian dragonfly. These organisms evolved here. They're a unique species and only exist on this island. In fact, Hawaii has more endemic species than any other island archipelago that I know of. It is an incredible place. And what we're going to be looking at and investigating is, how did that happen? Why does Hawaii have so many incredible endemic species? It's a story, and you gotta be here to get it. You're gonna love it. So, what is adaptive radiation? We know from earlier conversation that is the major key into what allowed all of these species to show up on the Hawaiian Islands after only a few of them actually migrated here. So in order to understand adaptive radiation, we have to go back to our concept of the niche. So what we've done here is each one of these lava rocks represents an available niche within the Hawaiian Islands, within this ecosystem. So we have 1, 2, 3, 4, 5, 6 niches that are available. All right, now, not all of the niches are the same size. This one's a little bit bigger, that one's a little bit smaller, and that's important. Okay, now, here's what we need to think about. On mainlands across the world, these niches also exist. But when on the mainland, these niches are filled with very interesting species. They're filled with that shell, and this shell, and that shell, and that shell, and that shell. And I want you to focus on this cowrie. This cowrie, a very bland, a very plain looking cowrie right here, occupies that niche on the mainland. That cowrie right there can't occupy any of these other niches because they're already being occupied by these other types of shells. If the cowrie tried to move into this niche, there would be competition, and we've been through that. It won't work. This shell right here, this tusk shell, outcompetes the cowrie, so the cowrie cannot be in this niche. So the cowrie's realized niche is a really small one. Okay, now here's where it gets interesting. Let's take these shells all away because none of these made it to Hawaii. They're all still on the mainland. For whatever reason, this incredible cowrie right here, whatever circumstances happen, whatever accidental storm or drifting of debris, this cowrie made it to Hawaii. And when it landed on Hawaii, it was able to utilize the first niche it came across. And here's where it gets incredible. You see, all of the rest of these niches on the Hawaiian island are open. They haven't been occupied by another living thing yet. Take a guess. I want you to think for 30 seconds and then we'll come back. What do you think happens to these available niches? Where do you think this cowrie can go? We'll be back. Think it through. I'm sure you thought it through. And I'm sure it clicked in your head what the magic really is. You see, once this calorie lands here, this plain calorie, which can occupy this niche, once it gets to the island, all of these other niches are totally available. So that calorie can then move into these other niches and expand the area in which it can survive. And here's where it gets just explosive, and we start to generate brand new forms, because this niche over here is different from this one, and this niche right here is different from all of the others. See, each niche is slightly different because it requires slightly different attributes. So over hundreds of thousands of years, this calorie, as it moves into these different niches, begins to evolve and change to best suit that niche. So instead of this calorie looking just like that, we have a new type of shape, a new color that best fits that environment. We have another new one right here. This one, it's rounder and it's smoother. Well, that one's best to fit that environment. But the original calorie that gave the genetic material came from this original founding calorie. And it continues to spread. It spreads into these crazy designs that occupy all of these totally different niches, until eventually every niche is filled again. But instead of those niches being filled with organisms from the mainland, they're filled with ancestors, or descendants from the original founding calorie. It radiates out into a new set of calories. So let's rearrange these niches into an arc that looks just like a type of radiation. And here we go. A single calorie that lands can radiate into all of these different forms. That's called adaptive radiation. It's when a founding species can occupy available niches, and those individuals that occupy those niches change over time to be best suited. This then can lead to our next interesting phenomena called speciation. How do species form? Well, what we're going to do is let's start that discussion by taking a look at this grouping of shells. What I'd like you to do is break this group into two smaller groups. And I think you would do that by looking at their shape. And you would pull these cone-shaped individuals and put them in a group, and these more bulbous-shaped individuals and put them into a group. And that would be an absolutely normal way to do this. And you would pretty darn close to separating them up into different species, because these individuals over here are not interacting and, most importantly, reproducing with these individuals over here. They live in a different way, and these live in a different way. Okay, we've separated that out. Now, let's eliminate these cone shells, because let's go back to our original example in Hawaii. The founding calorie shell that gets to Hawaii, lands in Hawaii. That founding calorie shell now has all of the available niches that we talked about earlier to fill. So when it has babies, and remember, when they have babies, they don't have babies that are identical to themselves. They have babies of all different shapes and sizes. It's called variety, or natural variation. So when those babies are born and they occupy the other niches, those babies are able to stay alive because they're not competing for a single niche. They can find a way to live on the island because there's available resources. And what we call this is adaptive radiation. When a single species, which occupies one niche, has offspring that then reach out and occupy other available niches, well, We call that adaptive radiation. But at this point, they're not different species. They're definitely still the same species. And we know that because this individual here is still able to reproduce with the founding individual, or at least it's able to reproduce with some of these other individuals in the radiated group. Here's how speciation happens. Well, all of these cowrie shells are existing in different niches, but in relatively the same location. But what if this happens? A volcanic eruption happens, and a lava flow separates these cowries from these cowries. It's a physical barrier. It's a separation. So even though these cowries over here are genetically similar to these over there at the time of the break, after the break, these cowries are no longer able to reproduce with these individuals over here. And if thousands or hundreds of thousands of years go by and these cowries remain isolated that entire time, well, that environment on this side of the lava flow is very different than the environment on this side of the lava flow. And over time, mutations can build up in these individuals that can prevent them, if that lava flow erodes away and now they're able to go back and hang out with each other, these individuals have changed so much that they're no longer able to reproduce with these. And now we've called these a separate species from these. That's speciation. The key to speciation is realizing that there must be a barrier. A barrier has to isolate those individuals from each other for an extended period of time, enough time for a mutation to build up, or enough mutations to build up to keep them from being able to reproduce. Now, the tricky thing is about this is that the barriers don't have to be physical. They don't have to be a lava flow. They could be a time barrier, meaning, or a behavior barrier. If this individual now only reproduces in the nighttime and this individual only reproduces in the daytime, well, that's going to be a temporal barrier or a behavioral barrier. So whatever barrier you have, and you have to have one, if it is in between these individuals and there's enough time that goes by, you can get individual species.